In this video, we're going to talk about how to factor problems that involve multiple steps. So no matter what type of factoring you're doing or what type of problem you're given, you should always start every single factoring problem by looking for the GCF, by looking for that greatest common factor. And if there is a greatest common factor between all of the terms, step number one is always going to be to factor it out. Then after you factor it out, you can kind of see whether you're done, you're finished with factoring, or if you're still left with the trinomial, you might have to do one more step and factor that trinomial. So we're going to look at two problems that are going to involve a couple steps. So the first problem we're going to look at here is 2x squared minus 32x plus 126. So it's a trinomial, but still our first step is going to be to look for that greatest common factor. Is there a number that goes into both 2x squared, 32x, and 126 evenly that we can factor out? So our first step, we're going to see that the greatest common factor is going to be 2. I can easily divide each of those numbers by 2 to make this problem a little bit simpler. But instead of dividing, we're going to factor it out. So remember, we put the greatest common factor on the outside of our parentheses, and then we put what is left over. When we distribute that 2, what is left over inside of the parentheses. So I know 2 times x squared will get us back to that 2x squared. I know 2 times negative 16x will equal 32x. And I know 2 times 63 is going to get us back to that 126. So my first step there was to find that greatest common factor and factor it out. But now we can see that we're left with a trinomial inside the parentheses here that we still need to factor further. And the directions say to factor completely. So we're going to leave that greatest common factor on the outside, that 2, but now I know I need to split up this trinomial into 2 binomials that are going to be multiplied together. So just like always, we need to find numbers that multiply to that 63 at the end, and that when we multiply, when we guess and check, it equals x squared minus 16x plus 63. I can see that both of my factors are going to have to be a negative number because we need them to multiply to a positive 63, and eventually they will add up to a negative 16x. X times x is going to get us to that x squared, and now I'm going to write out all my factors of 63. So here are my 3 options of what my factors could be, and I can see that only one option is going to actually get us to multiply to this original polynomial, and that would be x minus 7 and x minus 9. Let's not forget to check to make sure this is correct before we move on to the next one. So I'm going to start by checking my 2 binomials. Again, I'm going to leave this 2, and I'm going to double distribute x minus 7 and x minus 9. I know x times x gets us x squared, and x times negative 9 gets negative 9x. Negative 7x, negative 7 times x is negative 7x, and negative 7 times negative 9 does get us at 63. We can combine these 2 middle terms. Negative 9 minus 7 does equal negative 16x. So we can see that that inside trinomial matches what's highlighted. But if we're remembering this GCF of that 2, my last step of checking is going to be to distribute this 2 to everything inside of the parentheses. And when I distribute that 2, we do see we get back to that original trinomial that we started with. So my final answer, my final factors, that 2 with the GCF on the outside, x minus 7 times x minus 9. Example number 2 is also a factor completely trinomial. Again, step 1 is see if we can find a greatest common factor. And a hint that you're going to want to find a greatest common factor is that we're not starting with a quadratic. This is a quartic or a 4th degree polynomial, and we want to always be factoring quadratics if we can. So our greatest common factor is going to help us with our factoring. So we're looking for the GCF amongst the numbers and against the variables, and the GCF ends up being 4x squared. I can evenly divide each of the numbers by 4, and each of my variables has at least 2 x's in its expanded form to give up. So once again, I'm going to put the greatest common factor on the outside of my parentheses and figure out what I need to multiply by to get back to that original polynomial. So 4x squared times 7x squared is 28x to the fourth. 4x squared times 4x gets us 16x to the third. And 4x times negative 20 is going to get us to that negative 80x squared. So once again, this trinomial that's left inside of the parentheses is a quadratic, and we have to take it one further step and turn this trinomial into 2 binomials. So just like always, we are going to start by finding the factors of negative 20, and I'm going to list them out here. And you can see we sort of have double the options because of the negative. It does matter whether I put the negative with the 1 or the 20 or the 2 and the 10 or the 4 and the 5. So here are our options. And remember, we want those numbers to add up to 4, but we have to be careful with this type of problem. My first term in this problem is a 7x squared. So I know in my first binomial, I'm going to have a 7x instead of just a regular old x. 7x times x gives us 7x squared. So now I have to figure out what my second two numbers are going to be, that when we check, they mathematically add up to the 4x in the middle. After some guessing and checking, we should get 7x minus 10 and x plus 2. Let's prove that this is actually the same thing that we have factored correctly. So again, I'm going to start by multiplying my two binomials. I'm just going to leave my greatest common factor here. And I'm going to multiply, double distribute 7x minus 10 and x plus 2. So after double distributing, I'm not just adding together negative 10 and 2, I'm actually combining in the middle here 14x minus 10x, which does get us to that 4x in the middle in that new trinomial. And then if I want to take it one step further and distribute my GCF into my parentheses, I can see that we do end up with the same thing that we started. So therefore, 4x squared times 7x minus 10 times x plus 2 is the fully factored form of our original polynomial.